Today we are going to discuss the paired t-test, or the t-test for dependent means. And in the previous lecture we discussed the unpaired t-test, or the t-test for independent means. So today we are going to see that what is meant by the paired t-test and how this test is executed. So this test is also known as the matched samples t-test. Why this is known as the matched samples t-test? Because the samples, they are matched. The observations are matched with each other. And this is also known as the paired samples t-test. Why this is known as the paired samples t-test? Because the observations in the two groups, they are paired, right? So all the observations that we have, they are present in a pair of two. And this is also known as the dependent means t-test, because the observations in each of the pairs that we have, these observations are dependent on each other. So that is why it is known as the dependent means t-test. Then it is also known as the repeated measures t-test. Now, why this is known as the repeated measures t-test? Because the observations are they are repeated, right? The paired observations that we have, they are the repeated measures, which means that the same variable, it is measured twice from the same sample unit. So that is why these are paired, or these are dependent on each other. So these are the different names for this test, the paired t-test. Now, this test is commonly used to test the statistical difference between two time points. For example, we have cholesterol levels before and after the use of a medicine. So in this case, we are talking about an intervention study in which we have some individuals who suffer probably from the high cholesterol level, and we want to try a new drug on those patients. So we are going to take their cholesterol levels before the start of the treatment, and then we are going to take their cholesterol levels after the application of the medicine, after a few weeks or after a few months. So it means that we are going to take the observations in pairs from each individual. So let's suppose we have 5 individuals, so we are going to take 5 pairs of observations. The number of observations are 10, but the pairs are 5. So these are the paired observations, and each the observations in each of the pair are dependent on each other because they're taken from the same individual. And these are the repeated measures because the same variable is measured twice from each sample unit. And then this test is also used to test the statistical difference between two conditions. For example, blood pressure in resting condition and fever. And again, in this case, if we have individuals and we want to see that if there is a difference in their blood pressure when they are in resting healthy condition or when they are in fever. So we are going to measure their blood pressure in the resting healthy condition, and then we are going to take the readings of their blood pressure when they are suffering from high fever. And if you want to know that if there is a significant difference in the mean values of blood pressure in both of the conditions, then we can apply the paired t-test. Again, these are the paired observations which are taken from the same group of individuals. And these are repeated observations because they are taken at 2 different times, under 2 different conditions. And then the paired t-test is also applicable when we want to know the statistical difference between 2 sides or halves of the same unit. So in this case, we are not taking the observations under 2 different conditions. We are not taking the observations at 2 different time points. Rather, we are taking the observation at the same point, but this time we are taking observations from 2 halves of the same individual. So for example, if we are going to take measurements for the variable or for the object which is present twice on each subject, right? For example, the human beings, we are symmetrical for the ears, so we have 1 ear on each side of our body. So if we want to see that is there a statistical difference in the degree of hearing impairment between our group of individuals between the 2 ears. So for that purpose, we are going to use the paired t-test. So in this case, we are again taking the repeated measures because we are taking the same observation 2 times from the same individual, right? And this is also the dependent mean because the individual is same and we are taking paired observations. We are taking 2 observations from the same individual. So these are the general conditions in which we can apply the paired t-test. Now let's see what are the requirements of the paired t-test. The first requirement, as its name indicates, is that the two sets of scores or two sets of observations, they are paired or matched in some way. So the two observations, they should not be independent of each other, rather they should be paired. And the data is normally distributed, that the observations, they follow a normal distribution pattern. And the scale of measurement should be interval or ratio. It means that this kind of t-test can be applied on the continuous variable that is measured on the interval or the ratio scale. And this paired t-test is not appropriate for analysis of unpaired data. So if you have two groups and you want to compare their mean values, and if the observations, they are not paired, then you can apply the t-test for independent means. So you cannot use the paired t-test for that purpose. And it is not appropriate for the analysis of comparisons between more than two units or groups. So it means that you cannot apply the paired t-test when you have more than two groups. So it can be applied only on the two groups. And same is true for the independent samples t-test, that the independent samples t-test can also be performed only on two groups. So it cannot be performed on more than two groups. And it is also not appropriate for the analysis of a continuous variable that is not normally distributed. So it should follow a normal distribution pattern. And similarly, it is not appropriate for the analysis of the outcome which is ordinal or ranked. So it is not good for the observations which are measured on the ordinal or ranked scale or on the nominal scale. So it is good only for the observations which are measured on the interval or the ratio scale. So this is where we can or we cannot apply the paired t-test.